Thanks. Welcome to my presentation today about virtual network service scheduling in edge and cloud networks. I'm Teresa Yu Bi, a research associate from the Smart Internet Lab. So I will introduce the background and define the scheduling problem and the research motivation, and then design the multi-agent deep reinforcement learning algorithm for solving such scheduling problem. And then I will provide a simulation setup and the results. In the end, I will give the conclusion. So for the future 6G network, there are three pillar technologies. The first one is the network function virtualization, which separates the hardware from the software and enable the flexibility of service deployment and the resource usage. The second one is the edge computing, which brings computing resource from the cloud and enable the high data rate and ultra low latency services. The third one is the AI and the machine learning, which lead us to the new era of Internet of Intelligence. This is a simplified network topology, including the access network, metro network, and co-network. The MAC servers, edge data centers, and remote data centers, they are holding different amounts of computing resources. Network services can be represented by a service function chains with different end-to-end latency requirements. And find the proper place to process these virtual network functions and the time slot. The problem can be defined as the service function chain scheduling problem. In my solution, I model this problem as a flexible job shop scheduling models, which allows the VNFs to be processed by any same type of VNF instances in the network. And given all the resource constraints, this problem needs to decide first on which VNF instance the traffic should be processed, second, on which link the traffic should be transmitted, and the third, in which time slot the traffic should be executed. The research motivation, I summarize it into two aspects. The first one is the problem itself, because this scheduling problem needs to support the strict and diverse QoS requirements in the same network infrastructure, and it requires a scalable solutions. Also considering the limited resource on the MAC nodes, we need to dynamically utilize these resources and avoid the congestion during peak hours. Then for the stochastically service arriving, we need to deal with the dynamic and unforeseeable network environment. The second challenge is because we are going to use a multi-agent deep reinforcement learning algorithm. It has some challenges I list here, like non-stationarity, scalability, partial observability, and privacy and security. So I'm going to combine the edge computing, network function virtualization, and the optical technologies together and provide a solution, a multi-layer solution. This figure shows an example of the service function chain scheduling. Here we can see all of the service chain requests. Each network functions, the M1, M2, M3, and M3, they means different types of the virtual network functions. And these virtual network functions will be placed at each computing nodes. And this subfigure shows the example of the scheduling results. In my design, the multi-agent DRL models, the state is the network status and the service chain requests. The action include the node mapping results, link mapping results at each time step. And the environment, I model it as an MLP model. For the objectives, I consider two scenarios. The first one is the fully operational scenario, where all agents maximize the number of accepted service requests. And the second one is the self-interest scenario, where MIC agents maximize the number of ultra-low latency service requests, and the data center agents maximize the overall service requests. And this is MADDPG algorithm modified for this problem. This is a simulation setup. In general, I consider 5 class services. according to their latency and bandwidth requirement. And 6 types of virtual network functions. And the service request setting parameters and VNF required resource and the properties parameters that are listed in these 2 tables. And this figure shows the simulation topology I considered. Then it's about the simulation results. First, I test the service acceptance ratio of these 2 scenarios. As we can see, in the fully cooperation scenario, it can achieve more service request. But the self-interest scenario, it improved the service acceptance performance for ultra-low latency services. And then for the rewards, because the fully cooperational scenario can accept more resource, so it can achieve more rewards. And then this figure about the max CPU utilization ratio. And because the self-interest scenario has the capability to accept more ultra-low latency services at edge network, so it can use more max CPU resource. So in conclusion, I do the modeling algorithm and also carried out a simulation for this service function chains scheduling problem. It is actually the first work provided the macroscope modeling for this service function chain problem to solve it in a reactive network scenario. And in the future, I will do more centralized and distributed benchmarks, involve more benchmarks, and develop more competitive multi-agent algorithms in the future. Yeah, that's my presentation. Any questions?
Thank you very much, Teresa. Thank you very much. We have a question by Rajkarn Singh. The question is, how easy or difficult was the training of RL models, MA, DDPG, etc.?
How easy or difficult was the training of our? It's not difficult because it's a multi-agent one. Although I consider a big network scenario, and actually there's lots of the action space is very big, but because I divided it from the single agent to multi-agent, so for each agent the action space is not that large. So the training compared to the centralized one, the training is easy, I think.
Thank you, Teresa. Any other questions? Okay, I have a question. You said in your final slide that this is the first time this type of approach has been adopted. What do you think is the single most important benefit of adopting this particular approach compared to what we have, compared to what you have found in the state of the art and related literature?
What's the benefits of using multi-agent reinforcement learning?
Yeah, your approach.
Yeah. Yes, that's a benefit of this approach itself, and it's also works for the real world scenario. For example, there's some entrepreneurs who can in their network they cannot share information with the public network. So if we make them the independent autonomous agent, they can make decisions on their own. Yeah.
Okay, thank you very much.
Thank you.
Thank you. Okay, I am not seeing any other open questions, so thank you very much, Teresa.